So today we are going to discuss the effective nuclear charge. Okay, how to calculate this effective nuclear charge, how to give this jet star, or we say jet effective, jet effective or jet star we say here. So how to find out this jet effective here, effective nuclear charge, atomic number minus sigma. So the sigma indicates what here? Screening constant. Sigma indicates what? Screening or shielding constant. Shielding constant. So how to find out this screening constant? We are going to discuss. The Z value atomic number of the atom we know. So the sigma indicates what we have screening constant, whose value we are going to discuss. So to calculate this screening constant, we use what now? Slater's rule. So which rules will be followed here? Slater's. I'm listing Slater here. So Slater's rules are followed to calculate what now? This sigma value. What is sigma called here? Screening constant. Suppose we take the electronic configuration of zinc. Okay. So zinc, how many electrons are there? 30. So what is the electronic configuration? 1s2, 2s2, 2p6, 3s2, 3p6. And here, listen, when you are writing 4s2, we should not write here. We should write 4s2 after 3d only. So S, P, D, all of 3 orbitals should be written here. And remember that when you're writing here, a first orbit, 1s, and second orbit, 2s, 2p, third orbit, 3s, 3p, and d orbitals should be separately taken here. D orbitals should be taken separately. So if f orbitals are present also, d and f should be taken same group. Like this. Suppose here s and p taken as same group now here, 3s and 3p forming same here. We have to group d and f orbitals together. But here f orbitals are not there here. So d separately we have to write after 3s and 3p. And next 4s. So like this first we have to write. According to Slater's rules, the first rule is what? For this given atom, the electronic configuration must be written in this form here. Like this we have to first. Next, now what they have asked is that on 4s electron, how much effective nuclear charge is active? On 4s electron, how much effective nuclear charge is acting? That they are asking the question. Now here. So since sigma is calculated for 1 electron in 4s shell or 4s orbital, so 1 electron is left in 4s shell. Totally, how many electrons are there in 4s? 2 electrons there. Na? How to write the 2 electrons there? 1 plus 1. 1 plus 1 we have to write. So here, out of 2 electrons of 4s, 1 electron, on 1 electron we are calculating sigma value. Other than 1 electron, how many there? 1 more electron is there. That's what is given here. So now in 4s, 2, 1 plus 1 means on 1 electron we are calculating sigma value. That's one. Next will be. Now the sigma value is nothing but screening constant or shielding constant. So the shielding constant or screening constant, how to calculate is here. See. Now number of electrons left in 4s orbital means here other than this 1 electron selected, remaining how many there here? Number of electrons left, how many? 1. So 1 electron left over into 0.35 here. 1 electron left over into 0.35. This value is given by whom? Later. Understand what? Later. So Slater's rule we are calculating. We are using to calculate which value is sigma value. So in this case, here 1 electron in 4s orbital left over into 0.35. This value is constant given by Slater. Plus, next you see after this 4s, before 4s, left side what is there now here? 3d, 10, 4s2, 3p, 6. Now in the third orbit, totally how many electrons are there? 2 plus 6, 8, 8 plus 10, 18. So 18 electrons there here. In which orbit? Third orbit. So 3s, 3p, 3c, 3d. Together, how many electrons are there? 18 electrons there. So now here, if n value 4, if outermost orbit number 4, and what is n minus 1? N minus 1, how much? 3. N value 4, 4 minus 1, how much now? 3. So this is what now? Penultimate orbit. Third orbit is what now here? Penultimate orbit. Penultimate orbit without taking care. And what is outermost orbit here? 4. Outermost orbit is what? 4 here. And what is second last? Third. Fourth is the outermost. Third is what? Second last. The second last is called penultimate orbit. So in penultimate orbit means third orbit. How many electrons totally there? 2 plus 6 plus 10, 18 there. So 18 electrons into 0.85. So this value also constant given by Slater. Okay, 18 into 0.85 plus. Now see, other than this. Now, what is this 2 here? N minus 2 or n minus 1? N minus 2. The second orbit is what? If n value 4, suppose. If n value 4, what is n minus 2? 2. N minus 2 orbit is called anti-penultimate. What is the name of this? Anti-penultimate. Anti-penultimate orbit. And other than this, one is what now here? N minus 3. N minus 3. No special name for this, n minus 3. So here, n is fourth orbit, n minus 1 is third orbit, n minus 2 is second orbit, n minus 3 is first orbit. Now, here n minus 2 electrons and n minus 3 electrons. How many there? 2 plus 6, 8. 8 plus 2, how many? 10. So remaining all electrons, how many there? 10 electrons. It's 10 electrons into 1. 10 electrons into 1. So here, what we have to understand is that here contribution of electrons is 0.35 and contribution towards screening effect is 0.85 here. The contribution towards shielding effect is what here? Screening effect 1 here. Now tell me, this 1 electron is what? From nth orbit. From which orbit? Nth orbit. And this 18 electrons what? From n minus 1 orbit. N minus 1 orbit. Means n minus 1 is what now? Penultimate. Penultimate, how many electrons there? 18. 18 into 0.85. And what is this 10 here? Remaining all electrons. Other than n minus 1. Other than n minus 1, remaining all electrons. Remaining all electrons. How many are remaining all electrons? 10 electrons. This 10 electrons into what we have to do? 1. So now when you take this addition of all these values, how much you get? 25.65. What we have got? 25.65 we got here. It is which value? Sigma value. Sigma value. Now what they have asked you to calculate here? Effective nuclear charge. Effective nuclear charge. So what we have to do now? What minus what we have to take here? Atomic number of zinc, how much? 30 minus here sigma value, how much? 25.65.
25.65.
How much we get now? Tell me. Z effective. Z effective is equal to atomic number Z value, how much? 30 minus what is the screening constant value we got here? 25.65 we got. That equals to how much we get?
24.35.
4.35 is what now? Effective nuclear charge on which electron? My here this one. Effective nuclear charge on which electron? On 4s electron. On which electron? On 4s electron. Of which atom? Of zinc atom.
Zinc.
Okay. On 4s electron of zinc atom, how much effective nuclear charge is there here? 4.35. Okay. So this way we have to calculate what now? The effective nuclear charge, which is called effective atomic number. Actual atomic number of zinc, how much here? 30. But effective atomic number is what? Is 4.35. So this point we have to touch. Is that clear now? Do you all understand concept?
Yes, sir.
Now
Yes, sir.
also sometimes they ask you calculate the Z effective nuclear charge of D electron. They ask you not 4s electron in 3D. In 3D also electrons there na on 3D electron. What will be electronic means what will be effective nuclear charge? They ask that we are going to discuss. So it's about what now? The calculation of effective nuclear charge on which electron? 4s electron of D. Next again. Now here. Now screening constant value. What is screening constant? How it is represented? Sigma. Sigma value. So the screening constant value for which electron of 3D electron in zinc atom. Okay. Now for 3D electron, how to calculate it? First, zinc, how many electrons are there? Atomic number, how much? 30 here. Atomic number 30. How to get electronic configuration? 1s, next 2s, 2p, next 3s, 3p, S and P we have to write together. S and P, 3s, 3p, and D separately we have to write. I told now. D separately we have to mention, and then 4s. Now tell me here on which electron, on which means in which orbital we are calculating the effective nuclear charge on the 3D electron now.
Uh,
Now try
yes,
to
sir.
understand that. Now these two electrons of 4s, two electrons of 4s are on which side? Right side of 3D or left side of 3D?
Right side.
Right side. On right side of what? 3D. That's why these two electrons of 4s will have no shielding effect on 3D electron. Why these two electrons will not have any screening effect on this? Because these two electrons are outside the third orbit or inside the third orbit, outside the 3D. Outside the 3D, 4s electrons there. That's why we cannot take these two electrons to consideration because they are on the right side of 3D. Now tell me. Now within the 3D, how many electrons are available here? 10 electrons there. These 10 electrons, how to divide? 9 electrons plus 1 electron. Now on which electron we are calculating effective nuclear charge? On 1 electron of 3D we are calculating. So this electron is selected electron. On this selected electron, the screening effect or screening constant we are going to calculate from 3D orbit. Children, did you understand why we wrote 9 plus 1 here? Out of 10 electrons here, 9 plus 1 we have to write. Suppose if 5 electrons are there, they have to write 4 plus 1. If 3 electrons are there in 3D, 3 electrons are there, 2 plus 1. Like that we have to write. So first 1 electron should be separated and remaining electrons, how many? 9 there. Up to that clear concept?
Yes,
Now,
sir.
now
Yes, sir.
here from right side to left side we have to calculate. Now from right side is taken. Now other than 1 electron, how many electrons are available here? 9 there. So 9 electrons. 9 electrons into what we have to 0.35. Value is constant 0.35. So 9 electrons of 3D into 0.35. And contribution of each electron, how much here? 0.3. Next. Now, other than 3D, now 4s, 3p, sorry, 3s, 3p, how many electrons are available? 2 plus 6. 2 plus 6, how many here? 8 electrons. So 8 electrons from 3s2 and 3p. And try to understand that whenever we are calculating the Z effective of D electrons, other than this 3D, remaining all electrons must be contributing one only. Only one will be contribution for all other electrons. We need not to take 0.85 here. 0.85 will not be there when we are calculating Z effective of 3D electrons. Now within the 3D, 9 electrons exerting how much? 0.35 each. But remaining all electrons here, remaining all should be taken into one only. Here, now with 3s, 3p, 2 plus 6, 8 electrons there, 8 into 1. Plus, again, 2s, 2p, how many electrons there? 2s, 2p, 2 plus 6, 8 electrons again. again into 1 only, plus, and in 1s, how many electrons are there? 2 electrons there. So 2 electrons into 1, 2 electrons into 1. So totally how much we got now? Sigma value we got 21.15. Now tell me, what is the atomic number of zinc? What is the
30.
atomic number of zinc? 30. 30 minus what we have to do now?
30 minus 21.15.
21 point. That's why the Z effective on which electron? 3D or 4s?
3D.
On 3D electron is equal to Z effective on 3D electron is equal to what now? Z atomic number minus sigma. What is the atomic number of zinc here? 30 minus sigma value. How much we got from Clayton's rule? 21 point.
21.15.
21.15.
It is equal to what here?
8.85.
8.85 is what now effective nuclear charge on which electron? 3D electron. Okay. So why we did not take these 2 electrons understood here? Why we did not take 2 electrons of 4s?
Yes, sir.
Sir, sir,
Yes.
like,
This side, because they are on the right side of 3D. But you should not confuse that. Like in Aufbau principle, according to Aufbau principle, first lower energy should be filled. First 4s should be filled. Then only 3D should be filled. This concept is there, na Aufbau principle, but this should not be followed.
Yes, sir.
This should not be followed. What they have taken concept here is 2 electrons in the 4th orbit and these 10 electrons in the 3rd orbit. So the 4th orbit will be away from 3rd orbit now. After 3rd orbit only 4s will come. That's why these 2 electrons should not be counted. That's why how to write understood here. 1s is the group and 2s.
sir, like, why do we take like after just at the letter of 3D? Why do we take 1 into 8, 1 into 8, 1 into 8? I didn't understand that.
Which one you didn't understand?
So like you took 1 into 8, 1 into 8 instead of taking 0.85.
Instead of that, you can take directly here. Okay. Other than 3D, how many electrons are available here? Tell me.
8.
Totally.
Sir, 18.
Other than 3D,
No,
how
no.
many electrons are 18 there now? Take 18
Yes,
into
sir.
1. Take all
Okay.
electrons 18. 18 into 1. 18. Same thing
Okay,
will
sir.
get. Same
Okay,
thing will
okay.
get. There is no change in that. Okay.
ठीक है, sir.
Is that clear, ma? To everyone?
Yes, sir.
Yeah. So it is about effective nuclear charge concept. Like this, we can calculate for anything, not only for this. Okay. Suppose next one. Next important one, what I wanted to discuss is, let's see. Now, suppose X-rays are there. X-rays. For this X-rays frequency, I am taking. Frequency is given by nu. Nu is what? Frequency of X-rays. Okay. And now listen carefully here. Atomic number Z can be related to frequency of the X-rays emitted by using what this equation. How these X-rays emitted here? Whenever cathode rays hit, when cathode rays hit one heavy metal. Which metal? Heavy metal. Heavy metal with atomic number what now? Z. Atomic number of heavy metal is what now? Z. So whenever cathode rays bombard the heavy metal surface, okay, we get X-rays. What we get here? X-rays will be obtained or X-rays will be emitted. But these X-rays, what is frequency here? Nu. Nu is what here? Frequency. So frequency of X-rays produced is what? Nu here. And what is the atomic number of the metal used here? Z. Okay. So this experiment was conducted by scientist Moseley. So Moseley's equation will be. So this equation is called what? Moseley's equation. This equation is known as Moseley's equation. So what is this here? Check it here. So square root of nu. Nu is what your frequency. Square root of nu is equal to A into Z minus B. Where A and B both are constants. A and B are what now? Constants. Okay. And nu is what here? Nu is what frequency of X-rays emitted. And what is Z here? Atomic number of the metal. Okay. So this is what now experiment conducted by which scientist? Mostly. And this equation is known as what? Mostly equation. Tell me now same equation, how to write? Tell me. A of z minus b, how to write now?
Sir, a square z minus b ka whole square.
A into z minus a into b, we can write as this one. Tell me how to write. Square root of mu.
We can open the brackets.
Square root of mu is equal to a into z, az minus a into b, ab. Is that clear to this? Yeah, now check it here. Now in this case, if we take y is equal to mx a plus c. Equation of what this one?
Sir, slopes.
Equation of straight
Right.
line.
Equation of straight line, right? Equation of straight line we have. So here now in this case here on y-axis what we have taken here? Mu bar.
Sir, root of mu.
Right? Square root of mu. Square root of mu is taken on which axis? Y. And what is taken on x-axis here?
Atomic number.
Atomic. On x-axis what is taken? Atomic. And what is m here? Slope.
Slope of.
And what is c here? Intercept. Intercept on y-axis. So like this is the equation of straight line everyone knows, right?
Yes, sir.
Yeah, now you can get based on this one question we are taking. Suppose what is given is that the frequency symbol what? Nu. So frequency of the characteristic X-ray of K alpha line. Something they say here. K alpha, K beta, whatever it is. But the X-ray line, frequency of metal target M is given what now here? 2500 centimeter. So what is the frequency given here? 2500 centimeter inverse. It is what frequency given. Next, and the graph between square root of frequency versus Z is as follows. Then atomic number of metal. M is what here? Metal. M is metal. For this, what they are asking, atomic number they are asking. Atomic number of the metal they are asking by giving frequency. Tell me first of all equation. What is the equation here? Square root of mu is equal to what we wrote? A into Z.
A.
Z minus
Minus AB.
AB, right? And now tell me here, this slope is given here 45 degrees from theta. So what is tan theta here?
1.
Tan 45 degrees, how much?
1.
So what is given here? Slope is given indirectly. Directly they did not give, but slope is 1. This is clear. And what is the intercept here? OA is what now? Intercept now? Negative intercept. So now here OA, how much is given? Intercept. Intercept is B here. This B is what? Intercept. Intercept B is given what? 1 here. And what is this A here? Tell me. A is what? Slope. The slope, how much we got? 1. Okay. And B, how much is given here? B value. Intercept given 1 here.
1.
Is that clear? And now what is asked to calculate my here? Z value they ask. Z value they ask. Right? Tell me now. What is the value given? Frequency 2500 they give now. So right now, square root of 2500 is equal to, tell me, A value how much more? 1 into Z value we don't know. Z minus A value how much here? 1. 1 into B value how much given? 1. Right? You all getting concept or not? Now tell me here.
Yes, sir.
What is square root
Yes,
of
sir.
2500 now?
50.
1 into Z. Z minus 1 into 1. 1. Therefore, atomic number Z equals to what? 50 plus
51.
that is 50. So the answer is what now? Atomic number of the element is what now? 50. So like this, atomic number is how much here? Like this we have done. Is the concept clear to everyone? So on y-axis,
sir.
what is taken? On y-axis, what is taken? Square root of frequency taken. On x-axis, what is taken? Z and Z. X coordinate is what is Z. Y coordinate is square root of frequency. So this is one important concept. Okay. Hope everyone understood that.
Yes, sir.
The next one. Here. Now screening constant and effective atomic number of alkaline earth metals. Okay. Now see, first screening constant means which value? Sigma. Right? And what is the effective atomic number? Effective atomic number is nothing but Z effective. Z effective is what now? Effective atomic number. Are you hearing concept? So it is given like this. Now effective nuclear charge is nothing but effective atomic. For alkaline earth metals means for what are the elements here? Beryllium, magnesium, calcium, strontium, barium. For these elements, they are going to calculate. The radium we did not take because it is radioactive. Radium we did not take. Now tell me atomic number Z value how much for beryllium? 4. A Z value how much? 12. A Z value 20. Atomic number 38. Atomic number 52. Atomic numbers like this we got. Now screening constant. Screening constant. That is what sigma value. That is screening constant here. Sigma. So the sigma value we got like this. How we got understood this one? How we get the sigma constant is screening constant? How we get understood? Tell me now. Suppose beryllium. Tell me what will the electronic configuration? 1s2.
2s2.
2s. Can we group into 1s and 2s separate? And in 2s, how to write how many electrons available? 2 electrons there now.
1
1
plus
plus
1.
1.
1 plus 1.
1 plus 1. Now tell me sigma value is equal to here. How many electrons remaining here other than the selected?
1.
One.
1.
1 electron into 0.35.
35.
Yes. Other than n orbit,
Two.
n minus 1. Penultimate orbit has how
Two.
many electrons? 2 electrons.
2.
2 electrons into 0.85.
85.
0.85. Yeah, we have to take 0.85 because here we are calculating for s orbital now. For s orbital, we have to take 0.8 for the penultimate orbit. Tell me now how much it is? 0.35 plus 2 into 0.85. So we get sigma value. How much we get sigma value here? 2.05. Next, tell me how to get effective atomic number here. Effective atomic number, what is the formula? Z effective equal to what minus what? Atomic number minus 6. Now here atomic number how much for beryllium? 4. 4 minus sigma how much? 2.005. Then what will be effective atomic number here? 1.95. Like this. Now see, from beryllium to barium down the group, second A group, atomic number is increasing or decreasing? Down the group, atomic number is decreasing. The same way you see, effective atomic number also increasing or decreasing?
Sir,
Yes,
increasing.
remaining same. Remaining same. Atomic number generally increases or remains same, that's all. But will not decrease. Atomic number, effective atomic number will not decrease. It will increase either or remain same. So like this, effective nuclear charge can be calculated for it. And also they mentioned about what screening constant means sigma value. Sigma value and effective atomic number means what? Effective atomic number is nothing but Z effective of second period element. Now in second period, what will be elements? Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. What are atomic numbers here? Z values 3, 4, 5, 6, 7. Now screening constant means sigma value. Sigma value how to calculate? Understood now? So we
Yes,
have to
sir.
calculate sigma value.
Yes, sir.
After that, effective atomic number we have to calculate. Like this, effective atomic number, you check it here. Increasing or decreasing or remaining same?
Increasing. Sir.
Increasing.
Increasing, sir.
in a period from left to right, period from left to right, the effective atomic number is increasing and normal atomic
Yes.
number also, increasing.
Increasing.
In the group, what is happening here? The effective atomic number is increasing first and remaining. Is that clear?
Yes, sir.
Let's about what now here? Effective atomic number. Now, next, some more important points here. See, now this thing also I will send you today. Now, once again, go through all these points, important points here. Now, order of filling sublevels or subshells in fifth period. Fifth period means what I told you, n is equal to 6. Now, which orbitals will be filled with electrons? Ns, n minus
NP.
2, n minus 2f, n minus 1, d, np, last p, np. Okay, so which orbitals must be filled with electrons here? 6s, n value 6 na here, 6s, comma, here n minus 2 means 6 minus 2. 6 minus 2, how much? 4f. And n minus 1 indicates what here? 6 minus 1, how much? 5, 5d. And np in 6p. So see, these are the 6s, okay, 4f, 5d, 6p. How many electrons? Tell me. S can accommodate 2 electrons. F can accommodate 14 electrons. B can accommodate 10 electrons. P can accommodate 6 electrons. Totally how many? 32. So 32 elements will be present in this period, 6th period. 32 elements. So the 6th period is what? Which period? Longest or shortest? Longest. Period. Okay. And biggest group is what? Biggest group is what? Third group.
Sir, one.
Group 3. This group 3 is what now? Roman number 3b or 3a? 3b.
B.
How many elements in this also? 32 elements. How many elements in this? 32 elements will be present in group 3 also. Why 32 elements are there is that, see, in group 3 or Roman number 3b, there will be what? Scandium, yttrium, lanthanum, actinium. 4. These 4 we can see the table. At the bottom, how many lanthanoids and how many actinoids? At the bottom of table,
14 each.
lanthanoids, 14 actinoids. 14 plus 14, 28. 28 plus here, how many there? 4. This is what? Roman number 3b. Roman number 3b. So these 4 elements plus 14 plus 14. Totally how many elements? 32 elements. Okay. Biggest group is what? 3. And longest period is what? 6th period. Okay. Next. Again, order of sizes. Now it is anion, it is neutral atom, it is cation. What will be charged? Anion charge will be larger than neutral atom, parent atom. Parent atom size will be larger than cation. Okay. Next. Order of radii. So here n minus 3, 10 electrons. O minus 2, 10 electrons. F minus 10 electrons. N plus 1, 10 electrons. All these are having same number of electrons. What are they called? Isoelectronic species. Isoelectronic species. Same number of electrons are present. Now, which will be having more size here? N minus. Why? The negative charge is greater. So more negative charge, more size. Among what? Isoelectronic species. And here more positive charge. More positive charge indicates what? Small size. Point. Next, order of different types of radii. Which radius will be more? Van der Waals radius greater than metallic radius. Crystal radius means metallic radius. Greater than covalent radius. Okay. Next, for non-metals. For non-metals, generally, atomic radius is nothing but covalent radius. Okay. And for metals, atomic radius is nothing but the crystal radius. Na? This crystal radius generally will be greater than what? Covalent radius. Suppose they gave atomic radius of calcium is X and covalent radius will be less than X or more than X. If,
less than X.
if metallic radius of calcium is given 90 pm, suppose picometers, then what should be covalent radius? Less than 90, na? Less than 90, we have to take
Yes.
whatever the value given, whatever they give you, you have to take it. Next again. Now order of ionization potential of which period? Third period. Suppose if you get third period, what are the elements? Tell me. Sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon. Okay. Which one is having highest ionization potential always? Group 18
Argon.
means argon, inert gas. After that, halogen. After that, see, phosphorus and sulfur, which is group 15, which is group 16,
Group 15 phosphorus.
phosphorus. So phosphorus and 16 group, 15 group and 16 group, which will be having more ionization potential. 15.
There is less than 1 minute left. So are you going to share another link?
No. It's enough. Remaining already, we discussed all these points already. I'm explaining you as time is available. So this total PDF I will be sending you today. Please go through these points also. Okay. Because we have to study other subjects also now. Once again,
Yes,
go
sir.
through each and every point what I'm going to say. Okay.
Sir, I have a doubt.
Please tell me.
Sir, the values that you gave for that screening effect, the 0.35 and 0.85, are that constant?
Constant, yeah. All this.
Okay.
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 Okay. All the best, ma'am. Study well. Don't waste time. Tomorrow first examination.